Hello everyone and welcome back at CodingBulls. Today we will continue our regular C++ tutorial videos and we will take a look at more data types as well as we will solve some basic problems. Let's go ahead and open CodeBox and we will continue from where we left off. There is this course. If you want to save your codes and work on another file, you can go ahead, save it and create a new file the same way I showed you in the first video. Let's take a look at this variable type called arrays. Arrays can have any type of variables that I showed you in the last video and has more of these variables in a continuous line. So for example, this A array contains 10 integers. We can set any of its values. Let's say that the first one is 2 and the fifth one is 10. And we can output any of these values. And we click on the 10. You see that we got 2. So now if we want to take numbers from the console, we first take the size, and then we will input all of the characters. Now let's go ahead and make some operations with it. In this example, we will just multiply the values with its index. So the first element will be 0, the second will be itself, the third will be 2 times itself, so after it's done, we will output the values to the console. Let's say that we have 5 numbers. 5, 3, 10, 12, and 0. As you can see, we outputted 0, 3, 20, 36, and 0. So this is a simple example. As you can see, we have more of these 4 cycles. It's interesting to think over what happens if we remove these 4 cycles and put the code inside them. So if we go ahead and remove this, we can just comment it out. So I will show you the difference. So this way, we will input the first element, then multiply the first element, then output it. Then go on to the second element, get it from the console, multiply it, and output it. And as if we go back to the previous example, here we first input all of the numbers, then multiply all of them, then output all of them. So the order is different. But in this case, the order of these operations doesn't matter, so it's more convenient to use 1 for cycle, like this. So we go ahead and remove this, and as we can see, we stay the same. Let's input characters now, and we can see. Sometimes we separate the numbers with single space, and we just output on end of line after we are done. So in this way, our output will look better. Those of you who paid attention can see that the A array only contains 10 numbers. And maybe the input is bigger. In order to fix this, we usually have 2 sources to do. Create a const variable const means that its value cannot be changed after it's assigned, and this works the same as integer. And we have a variable here that means that its size will be the nth value, which means that 100,000. We usually want to put the maximum of the value that is possible here. So if we have a 100,000 number at most in any programming problem, or we estimate that's the maximum, we can use this. It's important to mention that this means that the index 99,999 still exists, but the index 100,000 doesn't. So if we want 100,000 to still exist, we need to put a 1 in the end. Now maybe we don't know the maximum value. Then we can use another data type, which is a vector. go ahead and just create a vector. So we have a vector of integers. It can be character, it can be integer, it can be string, it can even be another vector of anything. This is, for example, a vector of vectors of integer. First, I will show you the normal vector of integers. That means this is really similar to an array with few exceptions. Its size is not fixed, and we can always put more elements in it. So if we want these numbers to be put in the v vector instead of the a vector, go on and remove this slide. So we will have an integer here. We will take the input from the integer, and now if we want to add it to the array v, the vector v, then we will do v that dash back x. What this does is always also in the rest in the library. It puts the x to the last element of the vector, and if it needs, it resizes. Now we can go ahead and change the code for v, and we can output it and use it normally as an array. So if we go ahead and run it, you can see that we got an error that vector doesn't name a tab. This is because we need another library for the vector. So not just the stream, but we need to include the vector. And now if we better run it, you can see that it compiles and it works similarly as with the regular array. So we have all the solutions. Now, to make the coding much simpler, instead of all these libraries, there is a really powerful library that I recommend to use. Bits for a steady C++ to the edge. This is a very powerful library containing lots of other libraries, so you don't have to worry about including every other library in your code. So if you are using CodingBulls, this is a really good idea. Unfortunately, it's not possible in other programming ideas. For example, Visual Studio, you can't use it. But if you are in CodingBulls, I encourage you to use this library instead, so you don't have to include multiple libraries. And as you can see, it compiles like normal. Now, let's take a look of another program. Let's say that we want to take the numbers, and now we want to output them in order. The way we can do this is that first we just take the numbers, put it in the vector, and then after we have all the numbers, we can sort them. So the sort function takes two iterators and sorts everything between them according to their values. Iterators is a pointer to any reference point, and this .begin refers to the first element of the v, and this end refers to the element after the last element of v. So let's take a look. Let's say that we have this v vector here, and we have the values. Like this. So, the first begin operator will reference to this element. The end will refer to the element after the end, so outside of the array, but the first number before the array is this one. Now, what it does is basically goes through these and puts it in order. So you will receive 0, 1, 2, 4, 5, 13 in your v array as a result. Now we can just go ahead and go cycle. That put it. If we take a look, we copy the same example with 6 numbers 1, 2, 4, 5, and 13. Oh, and I forgot 0. So the result will be 0, 1, 2, 4, 5, and 13. Now we go until s. But what if we don't know the vector's current size and we want to do a full cycle? We can use instead v.size. This is the size of the array, similar to the strings, and we will go until them. In this example, it is the same because the s is just v's size because we put v s elements in v. Now let's take a look of another example of using vectors. We want to take some numbers and we want to output the sum of it. So we will have this vector, the input, and now instead of sorting, we will just increase the sum by its value in the first cycle. And we don't forget to enter the sum and give a default value of 0. And in the end, we will output the sum and the length. So in this first cycle, we go through all of the elements of v, we enter map, and output it. So if we have 0 elements, 4, 10, and minus 3, the sum may be 11. Now let's say that we want to add the absolute value of the values. We can use the absolute function. This way, sum of 4 minus 3 and 10 will be 17 instead. And we can do any other stuff with the value v in here. Now let's take a look of functions. We already saw how the functions work. I will show you a special kind of function called recursive function. So let's say that we have a function that takes 2 parameters. We go ahead and remove the vectors and the array in this code. So I will write the function and your task will be to figure out what it does. We take the input from the user and the output. You can see that I use different variable names in the main function and the function. It's completely clear. Go and pause and think about the solution, and we will come back after you're done. So let's test it out. But if I say 2 and 3, it will be 8. The solution that a function takes the fifth power of u, so 2 to the power of 3 is 8. We can see this is that if we go ahead and take a look at the function, if v is 0, we return 1. Everything to the power of 0 will be 1. Otherwise, we will return u times this f function. Now, this function is called recursive function because it refers to itself. Similar to loops, it can be infinite, and if I remove this -1, we will refer to the same parameters here, and it will run forever. And if we wait for a bit, we can see that we will actually get a stack overflow, meaning that we called too many functions in itself, and the program could not handle it, ran out of memory, and will crash soon. As you can see, the program is not responding and returned with an error value. So you need to be careful that it always returns something. Now, we take a look and see that we return u times the function of u and v minus 1. So we decrease the power by 1 and we multiply the result by u. Therefore, we will return the power. Now you would probably want to make the function long int instead, because it may return really high values even with relatively smaller u and v value. So we can repeat this and it works the same way. Another thing that you could see is what happens if v is negative. Well, if v is 0, we return 1, otherwise we take 1 out of v, but it will always remain negative, so it will run forever. So we want to make sure that we can't have negative values, so we probably want an unsigned int. So we have value and an unsigned int as v value. Another way to do it is tracking the function if v is less than 0. So this code is now correct and returns every time. But we can do something to make it work faster. In this else statement, what we can do is called fast powering. We take two cases. If v is even, which will be a modulo operator. This means that if we take the v of the modulo of 2, then if it's 0, meaning that it's even, then we will store the result of the function. We can assign the value in the same line, f u v divided by 2, and then return a times a. The reason this works is we take this function, which is the result of if we have the power of half of it, and now we return a times a, which will be equal. So the mathematical function will be that u to the power of v half multiplied by itself is the same as u to the multiple of u to the power of v. So we can use this trick, and otherwise we will return normally f. Now there is one more problem with this, is that we return long longitude, but this u is an integer. So if we multiply with an integer, it will be stored as an integer value. But if we go ahead and multiply this value with u, so if we change the order, it will actually be a long int, because this is a long int, the f value, and if we multiply with a long int, it will be a long int. So sometimes the order of this multiplication matters. Now we can also cast the u by having long int before. So now u will be considered a long integer. It will be casted and it will be treated like this. If we go ahead and print and run it, you can see it still works. 4 to the power 4 is 256. If statements, and the else statements is if you have only one expression after that, but only if you have only one, you can go ahead and remove the brackets, and only the next statement will be considered to be part of the function. Another thing is that we can also get rid of this else, because if this was true, then we already return 1. By the way you move this is you need to press tab to move them ahead and shift tab to move them back. So we already returned, and then we don't have to worry about if v was 0, we already returned. Same here, if v was even, we already returned, so we can keep this function simple. So to the power 4 is 81. Now you can't remove this here because you have two expressions, so you need to keep it. Now, common question is why can't you just instead multiply fu v2 by itself? The reason this is not good, and it will still work, but the reason this will be slow is the function will be executed twice. Every time you call the function, it will be executed. So if you have a large number, then let's say to the power of 10, then it will let's say what it does, we have, so it will execute twice the 5 byte, then we go ahead to the 2 to the power of 4 twice, and then when we calculating the 2 to the power of 4, we will actually calculate the 2 to the power of 2 4 times, and then 2 to the power of 1 8 times. So it exponentially grows, and it will be out of control really fast. So we want to make sure that we only call this function once, and then use its own value. And one last task for today is another function that will take one integer parameter, and what we want to do is return the 8th Fibonacci number. Fibonacci number is a sequence which starts with 1, 1, and then every element we pick the sum of the last 2 elements. So 2, 3, 5, 8, 13, and so on. So go ahead and think about how you can solve this problem. We will come back for the solution. As you might expect, we will need to use recursive functions. So if a is 0, then we will return 1 first value. And we also, if a is 1, we will return 1. Instead of making 2 separate if statements, we can go ahead and use the OR operator. This means that a is 0 or a is 1, then we will return 1. By the way, the pair of the OR operator is an AND. This means that if a is 0 and a is 1, then we will return 1, which obviously makes no sense because a can be 0 and 1 at the same time, but maybe we have another parameter b that we want to check. In this case, we want to use the OR operator. So if a is 0 or 1, then we will return 1. Otherwise, remember, we don't need the S part now because we already returned and stopped being in the function if a is 0 or 1. But if you want, you can still put the S, it's up to you. Otherwise, we will return f a minus 1 plus f a minus 2. So if we go and build and run it, and we want the 5th Fibonacci number, we can see that it will be 8. Now once again, this will be a bit slower because we call both of these functions. So it will grow exponentially, and we will actually count all of these twice. So if we have like a number 10 here, then we will call the f9 and the f8. But in the f9, we will call the f8 again. So we have the f8 twice. But because we have the f8 twice calculated, we calculate the f6 4 times, and so on, which is not really effective. In order to solve this, we can actually come up with another solution. Vector of long integers. And we'll change numbers. As you can see, you can have longer names. Let's make it just as you want. And instead of this function, we will have a void function that doesn't have a return value, but just makes a task. We will call it store numbers. And we will have a max value here. So what we will do is under Fibonacci numbers, we will push back 2 values, 1 and also 1. This will be the first 2 values, and then from 2 until we have x value, we will Fibonacci numbers. You can go ahead and start typing it. and then we take the Fibonacci numbers, and then push back. What do we want to push back? Fibonacci numbers e minus 1 plus Fibonacci numbers e minus 2. So the rest 2 elements we push back. Then we are done. We can either return, or in case, but only in case of void functions, we can actually not return, and it will return automatically at the end of the function. So in the main function, we will have a number. We take it as input. Then we will call the store Fibonacci numbers function. We want to calculate until a, until or we give one high value, and then we will output Fibonacci numbers e minus 1. Minus 1 because we index from 0 in the vector, and in the task we want to index from 1, so we need to add 1 here. If we go ahead and run it, just for the fifth Fibonacci number, we can see that it's 5. So make sure that indexing is correct. If one asks us if you want to index from 0 or 1, as you could see, in the first example we indexed from 0, and in this example we wanted to index to 1. Now, one more thing is that you might get bored of typing these longer names so often. So for example, this long int. You want to shorten it, let's say LL. Now, of course, the compiler won't understand what LL is, but you can type at the beginning of your code, type def long int, and that name, give a name LL. That means that the long integer can be called as LL. If we did it, now it understands. If you enjoyed today's episode, make sure to like and subscribe, and see you in the next video.